Right, let's make a start. Hello and welcome to this. It's our June 2021 virtual event. It's so good to see that so many of you could join us today. And we continue to see this as a great way to talk to you about the changing technical landscape and share our real world experiences with the dramatic shift that business IT has undergone in the last 18 months. While I'd love to be able to welcome you all to the Planet IT offices or to a conference suite in a swanky hotel, we look forward to being able to hold an in-person event very soon. Just a few housekeeping bits and pieces before we get started. For any questions that you do have during the entire process of this webinar, please use the question and answer function in Teams Live. One of our team is sat there and will certainly go through those questions, and as soon as we can get to them, we will get to them. Any questions that we cannot answer, we don't have time to answer during the course of this webinar, we will get back to everyone following the completion of the event. So for those of you who don't know Planet IT and maybe are joining this for the first time as one of your first Planet events you're joining, just to give you a little bit of a flavour to who we are and what makes Planet IT. So Planet IT is a one-stop shop for all of your IT needs, whether that be outsourced IT support through to voice and connectivity, backup and DR, your general day-to-day hardware purchasing, software purchasing, and as we're talking about today, cloud services. We really have a breadth that we're really proud of, to be honest, and we've got engineers that cover every aspect of the IT spectrum, from IT security through backup and DR into voice connectivity. We have professional services engineers that can help on any kind of project you have. That's really enough about us, just to give you a bit of a flavour for who we are. But more importantly, I suppose, who do you have with you today? So joining myself today, we have Adam Harrison, who is one of our technical architects and is very much security focused. I will let him tell you a bit more about himself shortly, but the most important thing today is that you're in good hands, and we're hopefully going to be able to help you understand this kind of cloud journey we're all on. So before I start talking all things moving to the cloud, a little bit more about me for those of you who don't know who I am. So I'm James Dell, and I'm the head of technical architecture at Planet IT. But I've not always been this side of the fence. For over 10 years, I worked in education, medical and retail settings, providing IT services in various roles. So I know firsthand the challenges of delivering IT solutions in what is an ever-changing landscape. So hopefully I can shed some light on some of these areas for you. So for many businesses, looking to a cloud and cloud-first strategy approach is the way forward. But I suppose before we can talk about why that's true, we need to consider what is a cloud-first approach. A cloud-first approach is where a business's mentality shifts to look at utilizing cloud services as much as possible, wherever possible, across every function of IT within a business. When a business adopts a cloud-first strategy, they look at new processes or review existing ones. They consider that cloud computing should be the first option that is looked at before any others are investigated. So obviously that's a massive dramatic shift from where we used to be, where for most businesses the approach was infrastructure first, tin on site, all about you owning it, you controlling it, being in your environment, to an approach where we look at, well, what can other people do for you and what kind of cost savings and benefits can we get from that? Now, this change in mindset for many businesses really kicked in about 2 years ago, when unfortunately COVID-19 dramatically changed the way that we work and interact with our working environments. At the end of the day, it's no good having a massive server room or a data center that you're not allowed to get to. And what good is IT in your office in a great environment that you've developed and you've worked in for years, when nobody's sat there, but everyone's sat at home on their sofas joining virtual meetings? You're getting very diminished returns at that point. So this sparked what for many is a shift in the way that they see IT services. And this is normally being driven from the top. So actually outside of the IT function, driven from your CEOs, your CFOs, and people who are looking at a board level about where can we make cost savings. And they want to see the ultimate shift from buying kit to buying services. And it's my belief that businesses should adopt a cloud-first approach and ask the questions of the business of what can be done better and what can be done better in the cloud. And is this even possible with a cloud workload? There is a few rare cases where it's not possible for these to be pure cloud solutions, but 9 times out of 10 in 2021, most things can be achieved in the cloud, and certainly with a cloud-first approach. So we know what a cloud-first approach is, but how do we really adopt as a business a cloud-first approach? Well, the first thing we've got to do is we've got to look at the groundwork. And when I say groundwork, what I mean is we need to educate and engage our stakeholders. That's at your CEOs, your CFOs, your board level. We need to clarify what business problems and strategic goals you have and develop and modify your existing strategy and validate that for a cloud world. You need to ensure that your objectives as a business and goals can be met by a cloud solution. Do the groundwork, understand if it's feasible. Can I put that resource into the cloud? Can I work in a global way? Is this doable with the requirements we have, maybe from compliances, things that you have to follow? Is it achievable? Once you've done that groundwork, you've established it can be achieved, we then move on to the foundation. And this is when we look at performing gap analysis and understanding what your current solution does, what does well, what can do better, and where you want to make improvements, and what the cloud could do for you. And this is where we look at things like return on investment, on how much floor space we're using up in the building for server rooms, or how much cost we're spending on private data centers. Understand where that leverage can be done. Finally, once we've kind of built the groundwork, we've put the foundations on top of it, we're going to blueprint out what a solution should look like. And when I say blueprint, the important thing is we're talking about a process that's going to be rinsed and repeated for different business processes. So there we're going to build a template of how a cloud solution works and integrates with your business, whether you still have on-premise environments to link it with, or whether you're using multiple clouds, in a way that you can link it together, and the design works to take away the hardest pieces of the conversation and make sure that you understand everything that's required, so that when you move from the design to implementation is the only way up, is up, and that everyone's going to benefit from the solution you've put forward. And the blueprint can then be used for the next business process that goes through this same approach, until you are taking that approach every time a business process needs to be reviewed, that you can know you've got the groundwork, you understand the foundation, and you've got a blueprint that works. So I've told you why we should look at cloud first and what I believe is a great approach to moving to the cloud. I suppose the big question is, this webinar today is moving to the cloud with Azure, and why are we talking about that? Why are we not talking about moving to the cloud with AWS or GCP? Well, for us, that's simple. In 95% of cases, Microsoft with Azure is the best fit for businesses who are currently using a Windows-based environment. Whether that's a physical or virtual environment, whether that's Windows endpoints, so Windows 10 and potentially Windows 11 soon, whether that's Windows Server, SQL Server, anything that's based around that Windows ecosystem works really well, obviously, with Microsoft Azure. Now, it does work with AWS and GCP, but it's not a native potential integration. So most of the time, we see Microsoft Azure as the place that SME, SMB, medium business want to be. For those 5% of cases that sit outside of that, GCP and AWS are a great fit. However, these solutions are normally for the kind of your DevOps, your engineering, your solution design, massive Linux platforms, things that are leveraging, Kubernetes or raw AI technologies. It's not necessarily people coming from a traditional workload. Now, don't get me wrong. AWS remains the largest platform for cloud services in the world, but that size is driven by a very small percentage of companies who use the platform potentially don't have a traditional workflow, a traditional SMB, SME medium workspace Microsoft built environment. They are new startups, they're massive tech companies, they're people who already have a environment that's cloud first and actually is built around no server environment, so it makes things very different. Now, there's some other reasons why you should look at Microsoft Azure. The first thing is that AWS is 5 times more expensive if you're running SQL Server on that platform. With Microsoft Azure, you have the ability to operate seamless hybrids between the two. It's built on an infrastructure which is future ready. So from a Microsoft point of view, everything they're doing with the latest version of Windows in the server and desktop side is designed to integrate in a hybrid way, in a way that will move towards the cloud naturally over time. Whereas, potentially there's other environments, they don't have those desktop environments that you can leverage and work together. And the final and big one for us and a lot of our customers is the global reach of Azure. Microsoft Azure exists in more global regions than any other cloud provider. So with that being in existence, it means you can actually have your data in more places closer to your users and be more efficient. And you can see on the right-hand side of the slide, the number of large customers that trust Microsoft with their infrastructure. And those companies from BMW to Samsung to Coca-Cola, these people don't put their infrastructure in place lightly. So you can, if these guys can trust them, there's a reason that that's in place. Now, some terms you'll hear banded around a lot when we talk about the cloud, and you'll see articles about the cloud, is this shared responsibility model, something that's always been very key, but never is very well explained. I put this slide in here because I feel like it's worth talking about, because it also tells us why we should be looking at a cloud first strategy. So the shared responsibility model takes on the premise of, if you're running all your infrastructure on premise, on your data center, in your server room, or in a private data center, there's a degree of responsibility around the actual physical side of things and the functional side of your operations that you're responsible for. Now, in an on-premise environment, you take complete ownership. So everything from making sure the physical data center is secure, the physical network is secure, the physical hosts are running and working and in support, the operating systems are updated, all that sits with you. Now, that's a lot of work and ultimately a lot of risk. When we look at moving across to infrastructure as a service with someone like Microsoft Azure, there's a change. Suddenly, a number of those items are no longer your responsibility, but then come with financially backed guarantees, something that as a business you wouldn't be able to do on your own. So with infrastructure as a service, the running of the host, the network, and the data center move to be Microsoft's responsibility, and they give you an 11 nines guarantee of how much uptime you're going to get from that solution, which is pretty impressive. So you 99 with 9 11s after it. It's a pretty impressive amount to stay online, something that I certainly wouldn't be able to guarantee in an infrastructure that I ran on premise, and I don't think that any IT manager would be able to confidently say they could. And if they are, they're probably a bit of smoke and mirrors going on there, because you can't really make those guarantees. You haven't got the global infrastructure that someone like Microsoft has got. But as we move down the scale, so as we start looking at platform as a service, something that when you move to something like Azure, you make a big change in terms of you don't always have to run everything as physical virtual machines. You can start being intelligent and smart with the way that your workload's set up, and you go, okay, well, we'll take something like SQL Server, take it off of a running Windows 2019 server and put it into a SQL service. Suddenly that's a platform as a service option, and even more of the responsibility then lies with Microsoft. So I haven't got to worry about patching my operating system for that. I also don't have to worry about network controls completely. Some of that is taken away. Some of that becomes Microsoft's responsibility. I have less to worry about on the application side, because SQL will run. I need to make sure that the operational side of it works, and then your identity and security as well is to a degree removed from your responsibility. Suddenly you've got less to worry about, and you can focus more on delivering a better service with the products you've got. The final step is when you go software as a service, and we look at the key one here, the one that everyone would think about, is Microsoft 365, obviously your Office suite, your Office in the cloud, as it were. That is an ideal example of how software as a service works. There's nothing for you to worry about other than the information and data that's in there, the devices you install it on, who has access to it, and where you have access to it from. Outside of that, that's Microsoft's problem. They need to make sure it's running. They need to make sure it's operating and that you can use it. And that's the key, is you're shifting that responsibility across to someone else. And that's where you can start adding value, because the time that your team potentially spends looking at keeping your physical data center running or your physical networking equipment can be moved when you move across to Microsoft Azure to focusing on making sure that the operating system's running better, or if you're doing platform as a service, that the application's running better for your end users. Now, there's always a conversation around, well, do I have to go all in, all cloud, or do I have to always stay on-prem with all my equipment that I own? And this is where that private versus hybrid versus public conversation starts. So when I say private cloud, what I mean is infrastructure that you own, and that's either running in your physical offices in a server room or a data center, or in a private data center that you rent out. When I say public cloud, I mean servers that are running in Microsoft Azure that are essentially on someone else's tin and operated in a different way and controlled outside of your remit. In the middle, we have this hybrid cloud approach. Now, hybrid cloud is exactly what you'd expect it to be. It's the best of both worlds. It's the best of having your own infrastructure and the best of having public cloud services. And if you do this right, and you put the right things in the right places, your end user experience is great, your security is really well controlled, and ultimately you get a really good compromise. Now, most people will do hybrid cloud as part of a route to cloud. With the intention being of, well, we'll jump to hybrid cloud and we'll have some on-premise, we'll have some in cloud, with the idea being that sometime we'll move all to cloud. But actually, hybrid cloud is a great place to continue to run for quite a lot of businesses. If you have a business critical SQL system that's massive, we're talking terabytes and terabytes of data, that's probably not best placed in Azure at the moment. But likewise, those small peripheral things that run around the outside of it maybe are better placed in Azure because they are closer to the end user. And you can use that kind of hybrid approach to get the best of both worlds. Now, I will say, if you're going down the hybrid approach, the one key thing to do is make sure that you really listen to what your users need and make sure that you're not just doing hybrid for the sake of doing it, because you can actually incur more costs because you're going to buy physical tin for your private cloud and you're going to be renting services on your public cloud side, and that can actually mean you end up double costing yourself rather than saving money. So it's a case of approaching it in the right way, and that's something that we can certainly help with, but it is about having those logical conversations at the start. Now, if you've been on one of our webinars before, you'll have heard about the 3-2-1 rule. When we talk about backups, we talk about it all the time. And the reason I'm posing this question today, because really, when we talk about the 3-2-1 rule, we're talking about a legacy approach. We're talking about 3 copies of your data, 2 locations, one of those being offsite. Now, going back 10 years, one of those offsite would have been tape. Now, one of those offsites being the cloud. But if you go all in public cloud, does this rule still apply? Well, luckily, Microsoft have kind of answered that question for us with a bit of a logical approach to the way they see data storage. So they have 3 tiers of redundancy inside of their storage, and they kind of answer the 3-2-1 rule. So the first one, LRS, or locally redundant storage, is what you get by default. Anything you put into Azure is based on an LRS approach. Now, what that means is that the data you upload is replicated to 3 separate locations inside a single data center. So if you imagine a huge data hall full of servers, it might be that in rack 1, server 1, your data's there, in rack 3, server 4, your data's there, and in rack 7, server 7, your data's there. That's their approach. If the entire entire data center disappeared, your data's gone, but if you lose 2 single servers, you continue to operate. It's that kind of approach of there's redundancy there. So they're giving you that inherent backup in the way that they design the solution. When we talk about zone redundancy, this takes that one step further. So this is putting 3 copies of your data into up to 3 data centers in 3 zones inside your chosen region. So for the UK, they have UK South, UK West, and there is a new data center coming up in UK North. Those data centers essentially can have 3 copies in themselves. So zone 1 will have 3 copies, zone 2 will have 3 copies, zone 3 will have 3 copies. But then ultimately you've got 9 distributed versions of your files. And because the link between zones inside Microsoft Azure network is low latency using dark fiber, ultimately, if a server fails over from zone 1 to zone 2 or zone 3 to zone 1, you will not know. Your end user will not know. The performance is untouched in terms of in local zone redundancy. Sorry, in zone redundancy, layered with LRS on top of it. Now, the final option is GRS. Now, all of these options obviously scale in cost, but you essentially are continuing to tick your 3-2-1 approach. GRS takes your data from your primary zone. So if that zone is UK South, which means you've got 3 copies of it in UK South, and copies it to a secondary zone outside of your geographic area. So for example, you can move that to Europe, the US, wherever that may choose to be, but you have another copy of your data in another data center. Now, because they're not low latency links, at that point, it is an invocation process to move your operations from running in primary zone to your secondary zone, but it's doable, and there's not this massive amount of downtime. The legacy backup approach of having to recover from a backup file, all that disappears, because if the primary zone goes down, I go onto the data in the secondary zone and I enable it and turn it on. Now, if the zone is distant to where I am, there may be ingress charges or egress charges for data, but ultimately I'm operational. Whereas on a traditional approach where I may have backups in the cloud, but I don't have infrastructure in the cloud, I've got to get that somewhere and I've got to recover it. So the 3-2-1 rule doesn't really apply when we move to fully blown public cloud. However, what it does do is gives you the ability to mirror that kind of approach with a number of places that you put data. So I think I've talked for long enough. And what I'm going to do now is I'm going to hand over to Adam to talk to you about security.
Thanks, James, and thank you all for joining us on this lovely afternoon. My name is Adam Harrison. I work as a technical architect at Planet IT. I've been with Planet for 2 years and in the industry for 12. I've worked various roles in support, infrastructure and security for both MSP and internal IT departments. So I have seen my fair share of different environments, both in the cloud and on-premise. So now you have your resources deployed into the Azure. The next obvious question is, how do you secure them? Well, you have a few options open to you. Azure has native tools that you can configure to protect your environment, such as role-based access control, network security groups, Azure Firewall, and more. But there are also a wealth of third-party solutions on the Azure Marketplace for firewall, optics, and other solutions. Let's discuss some of these options. So, role-based access control. Once you have deployed your resources in Azure, the next logical step is to restrict access via role-based access control. Access control is an important part of cloud governance, and it should be given the utmost priority. Implementing the right level of access control helps in achieving a secure Azure environment. Role-based access control is used for restricting network access based on the individual roles within an organization. It lets users have access to the information that they need and restricts them from accessing information that they don't. So it goes a little bit like this. You've got your security principal. That's the who, so that can be a user, a group, a service principal, or a managed identity. Got your scope, that's the what. So this can be a management group, subscription, resource group, or an individual resource. And that's the how role definition. Now there's over 120 built-in roles in Azure, and you can create your own if you like. But the 4 big ones are owner, contributor, reader, and access. User access administrator, and you can see right there in the middle how it all comes together. Next slide, please. There we go. So here in my example, you can see that there are multiple entries for the same user or group. There you go, now we can see it. This is because you can have multiple role assignments for the same user. This works by applying the higher privilege over the lower privilege. You should always use principle of least privilege when building your role-based access control policies. So in our example here, you'll see that we've got 2 entries for Alex. You'll be able to see that at the subscription level, Alex has been given contributor. That means it's been inherited into this resource. But you'll also see Alex has been given owner explicitly on this resource. In this case, owner would take precedence because it's the higher privilege. And the same with app developers. You'll see that with on the subscription, they've also been given contributor, but on this resource, they've explicitly been given reader. Well, contributor would override reader because it's the higher privilege. So network security groups. So when deploying your resources into Azure, you should also have configured the network security group for the resource within the virtual network it is attached to. This can be a virtual machine, a NIC, or a subnet. Next slide, please. So here's a little example I've put together. This is a demo environment, so any eagle-eyeds, anyone there that may notice a mistake. The destination should really be a public IP, but nevertheless, it is a demo environment. You'll see that there's a couple of rules there. The inbound web rules on port 80 and 443, coming from any source, well, it has to be any source because it's coming from the internet to a web server, is allowed to go to that destination. And that means that any traffic that comes over port 80 or 443, regardless of what it is allowed. So there's no traffic inspection there at all. You'll also see that there's the FTP inbounds. Being a web server, a lot of them are accessed via FTP from developers, but you'll notice that we've restricted it to a source IP, a trusted IP address. Yeah, that's again, anything over port 21, okay, it's restricted by the source IP, but anything will be able to go through. And you can see we've added the outbound, the cursory, allowing internet out from the server so they can browse the web. But is an NSG enough? Network security groups, are they enough to protect your environment? Well, quite frankly, no. Once the traffic rule matches the rule, it will process as configured. There's no traffic inspection such as IPS, IP reputation, lookup, anything like that. For that, you will need to add a firewall. So as you can see here, this is the overview page of literally, it's a brand new firewall I added for this purpose. So adding the Azure firewall to your virtual network will give you more security features than a network security group would. Threat intelligence and NAT rules are included. Next slide, please. For example, one additional protection you get with the Azure firewall is threat intelligence-based filtering, also known as advanced threat protection, which checks the inbound IP against Microsoft's bad reputation list and acts accordingly. You'll see that you can have it off, which obviously you don't want to do. You can have it to alert, but it will still let the traffic through. But the most common and the best thing to do here is have it on alert and deny. So you'll be told that there's a malicious connection, and it will also drop that connection. Additionally, also you can process source and destination NAT rules, as you can see down the bottom, and this is actually the right way of getting to the web server. You can see we've got the NAT there going to the external IP address of the Azure firewall, going to the internal IP, whereas the network security group does not have this functionality. It's worth briefly mentioning Azure Firewall Premium, as it is in public preview, but it's not out yet. This will include extra features such as web filtering, web application firewall, TLS or SSL inspection, exploit prevention or IPS, and more. Obviously, this will cost a little bit more than the normal Azure firewall, so you might want to check the Azure pricing plan calculator first, and also compare the cost with another third-party offering before actually making your decision. So while the Azure firewall is a good next step on from having a network security group, you will probably want to look at using a third-party firewall appliance from the marketplace. If you search the marketplace for firewall, you will get over 300 results, so there's plenty to choose from. These have multiple benefits over the native Azure firewall, such as cost, amount of features, and protection level. It can work out to be cheaper to get a third-party firewall than using the Azure firewall, and you get more features as a result. So you see on our little table here, you've got advanced threat protection, or threat intelligence, as Microsoft call it. You see the NSG doesn't do it, but then the Azure firewall and a third-party firewall will be able to do that. IPS, or exploit prevention, again, the NSG it's just not capable of doing it. The Azure firewall premium level will do it, but the standard version won't. Third-party firewalls, generally, that's straight in there out of the box. The same with web control. NSG just can't do it. Azure firewall premium can do it, and a third-party firewall will obviously do it. Obviously, features are dependent on what third-party firewall model you look at, and if you want to discuss any of these features in more detail, you can reach out. A web application firewall. So you see right at the bottom here, I've got web application firewall. That protects web applications from common exploits and vulnerabilities. Web applications are increasingly the targets of varied types of attacks, such as malicious bots, SQL injection attacks, and cross-site scripting, which can result in website sabotages, exfiltration of sensitive data, and application unavailability. If you are hosting an internet-facing site or application in Azure, then you absolutely need to protect it with a web application firewall. As you can see by my table, Azure provides its own web application firewall, but not through Azure Firewall. It does it as part of its CDN, which is called Front Door. You can this can be used to secure websites and applications. This is an edge solution that will also provide app acceleration and HTTP failover. Note that these can be configured as part of a load balancing configuration within Azure, or as part of an availability group. So you don't need to use Front Door for any of that. That's just in Azure. So what if you need a more dedicated solution? Well, a lot of third-party firewalls now have a web application firewall, as I said earlier, integrated as standard. The Sophos XG, for example, can provide this protection with its built-in web server protection. It will provide web server protection such as minimum TLS version enforcement, so 1.2 onwards, for example, slow HTTP protection, URL form hardening, blocking bad reputation clients, and more. Also, there are an abundance of these in the Azure Marketplace as a standalone application. While I was putting together this resource, I searched the Marketplace for web application firewall yesterday. I got 112 results. So yeah, there's loads of them to choose from as well. So that's the perimeter sorted. Well, what about your servers? Do you still need antivirus on an Azure virtual machine? Well, yeah. A server in Azure is as vulnerable as a server on-premise and should be treated as such. Just piggybacking off what James said regarding shared responsibility model, Microsoft will provide the platform for you to build virtual machines on, but the operating system, applications built on that operating system, it's on you to make it secure. Obviously, this means patching and monthly updates, but you should also plan to install endpoint security on these servers. Treat these servers as if they were in your own server rack and connected to your own network. So what third-party solutions are out there? Well, these are some of the top, and then top half of this slide, these are some of the top third-party firewalls on the Azure Marketplace. Other security vendors are obviously available, but we would always recommend going with a solution that is Marketplace certified, and all of these are. Regarding antivirus, the endpoint security solution, Microsoft has no governance over what security applications you use. So you should deploy the endpoint security solutions onto your servers that you are comfortable running in your own internal environments. So whatever you're deploying naturally within your environment, Azure is an extension of your environment, so treat them the same. Feel free to reach out and discuss these or any other third-party application. So, cloud security posture management. Some of you may have already heard of that. So this is another consideration is the monitoring of your security solution. Azure has a range of native solutions to monitor your cloud environment, and additionally, other third-party vendors have made their solutions available on the marketplace too. So let's briefly run through the native tools in Azure. So you've got Azure Monitor, and that's a service that you can use to aggregate, analyze, and visualize metrics and log data from Azure and external data sources. It combines two other services, Application Insights and Log Analytics, and can integrate with a variety of machine learning and analytics tools. Azure Sentinel, this enables you to collect data on your infrastructure, devices, applications, and users for the purpose of threat detection. It includes built-in threat intelligence, and you can use it to perform threat hunting or automate threat responses. You can use Sentinel with Azure and external data sorted. Application Insights enables you to monitor and manage application performance and respond to issues. You can use it to monitor your development and release pipelines, or to trace issues. Application Insights is extendable through plugins and can integrate with apps service diagnostics. So Security Center is a service that enables you to centrally monitor and manage your infrastructure and security on premises or in Azure. It is based on agents that you deploy to your virtual machines and integrates with most Azure services. You can also use Security Center to analyze your security configurations and receive recommendations for optimization. And finally, Azure Defender. This is the premium version of the Azure Security Center and will continuously monitor your environment, creating security alerts when a vulnerability or suspicious activity is detected. This can also protect your hybrid environment by monitoring on-premise resources. So here you can see the overview page of the Azure Security Center. Note that you've got the insights on the top right, and also you've got regulatory compliance in the middle. From here, you can drill down. Most of these links are clickable, so you can drill down from this page into the section that you need to review the information required. And then the next slide, there we go. And here are the kind of recommendations it will give you. So if you look right at the bottom, you can see it's telling me to enable multi-factor authentications. There's some access and permissions I need to change, and a couple other things as well. I didn't do any configuration here. It will do this with no configuration. It will review your Azure subscription. It does it at the subscription level, and it will recommend accordingly. Now, obviously, there's a number of third-party solutions that do the same and more. Here's a brief selection of products that we know that do the same and can help you out. For example, they'll be able to review your Azure environment, and they can make recommendations, whether it's cost savings or security improvements. But feel free to reach out if you want any more information regarding any of those. Anything else? So keep it secure. Obviously, you need to ensure Windows and application updates are run on a regular schedule, and these resources are rebooted to apply those updates. Potentially these servers are going to be internet facing, so they obviously need to be completely up to date. Notifications, if possible, get notifications and alerts configured via email. So if something happens, whether it's an alert or recommendation, you know when to take action. Tighten up. Periodically review your firewall rules and RBAC policies, role-based access condition policies, revoking permissions when no longer required. And for me, one of the biggest ones is multi-factor authentications. Make sure you enable it, not just for Azure, but if you can enable it anywhere, do it. Especially for administrators, but for all of your users if you can. This prevents stolen credentials from being used. Phishing attacks happen, people fall for them, and the whole point of a phishing attack is to get your credentials. So if someone does get your credentials, well, they don't have your mobile, do they? So they won't be able to use them. So yeah, enable multi-factor authentication, people. So yeah, that's me signing off. Thank you for taking the time out to attend and listen to me talk about securing your Azure environment. I think you'll agree that when designing your cloud infrastructure, security should be at the forefront of your mind, and feel free to reach out to discuss further.
Thanks for that, Adam. That's really beneficial. Obviously on the screen now, you can see you've got myself, I'm on the right-hand side, Adam on the left, you've got our details there. If you do have anything you want to speak about on a one-to-one basis following this, feel free to reach out to us directly. Obviously, you can watch the recording back when we send this out. We're there for you to help with these kind of conversations. It is a bit of a minefield moving to public cloud, but we're here to help. So for those of you who've been following the Planet IT monthly events that we've been running all this year, our next event is on Thursday, the 29th of July at 2 p.m, our normal time slot. Next month, we're talking about managing and securing the modern workplace with Microsoft 365, directly following on that software as a service conversation that we potentially started today. You can sign up for this event today via our LinkedIn page. or if you reach out to your Plan IT account manager, they'll send you the details over. So what I'm going to do now is I'm just going to swap screens and I'm going to jump into the Q&A, and we're going to try and answer as many of your questions as we can. So hopefully we can do that. So 1 second. So we've had a question asked, which is how would you calculate the costs of moving to the cloud? So I'll just jump straight onto that one. So in terms of calculating the costs, it's initially quite a daunting prospect, really, when you say, well, how much is it going to cost me to move? Now, the best place to start is to allowing someone like myself or Adam to go through with you and run a tool that analyzes your workload. Now, we don't necessarily care about a virtual server and how many cores you've got allocated to it, or how much memory you've got allocated, how much disk. That will give us some information. What we really care about is what the machine's actually doing, because you get charged for your CPU usage and your memory usage by Azure based on real-term usage. So we want to get as close to that as we can. So from that, we can then gather that information and we can enter that into the cost calculator. It will then bring us back an estimation of how much it thinks, at worst case, it will cost to run your environment. Now, the one thing I say to everybody when we look that I talk to you about moving to Azure is that cost is a worst case scenario with no optimization. The main plan of moving to Azure should always be move your servers as they are, because you know they work, you know they function, and then work over a period of 3, 6, and 9 months to redefine that workload and move to more PaaS options or move to more SaaS options inside 365 to take away some of the workload that you previously ran on servers and be more dynamic in the way that you work. And we've seen that. So from going from a Windows server running SQL to a SQL service, you can make massive cost savings and get better performance. So it's about making those changes. I was saying there's another question that kind of directly ties into this as well, around what is the total cost of ownership on-premise versus cloud. And going back to what I said about the hybrid approach, it's very important to understand your real world costs of your on-premise server environment. Now, if you're in a private data center, that's potentially easier to calculate than most other people's costs for that, because you'll have a monthly running cost that you will be charged to you by the data center, and you have the purchase cost of your server. So you can work out your current total cost of ownership of your servers. Now, working out the total cost of ownership of the cloud is easy enough, because we know how much you're going to be charged per month, and we can times that out by the lifespan of how long you intend to run that service for. Trying to tie those two together is quite important, that you work out a way to slot those two pieces together and understand what the real world cost is. Now, if you don't have a cost of ownership for your on-premise server environment, it's very difficult to show a board or to show senior management a cost saving by moving to the cloud. That's why you've got to be careful about avoiding those hybrid conversations in a way where you're not scaling down your on-premise at the same time. If you're just about to enter a server refresh, you're at the right point to start looking at refreshing your servers in a more compact scale with a move to the cloud. If you've already done that piece, you've got to make sure that through the lifetime of that server, you're scaling that resource down in a way that doesn't mean that you wasted that investment. It's a fine balancing act, and I could talk about it all day, but it's something to certainly be aware of. So I just had another question come in, sorry. So step by step for an SME contemplating moving from Azure to or AWS. So realistically, if you're looking at making that move, the first place you need to start is the what you want to get out of it. So what do you do well at the moment, service-wise? What works really well for you, and what doesn't? So, you know, what is your current server environment running really well? Everyone's really happy with access. Everyone's working in the office. It works. Are people working from home? Is the VPN slow? Finding those pain points, because ultimately that's what will define how the resourcing looks and what you're going to do next. Once you've had that conversation around, okay, well, I've got this workload in Azure on-premise and it's slow, it's this, we can then start looking at what would the AWS or Azure environment look like? So what services would you put up into that? How would we spread those services around? What do you need in terms of access? What do you need in terms of speed? Starting to have those conversations around, you know, what the scale looks like. The actual moving piece, once we've done the groundwork, we've put that we've put the planning in place, and we've started to look at implementation, and we're happy with the chosen path of direction. It's actually pretty easy in terms of migration. So Microsoft do a great job for modern operating systems in supporting a direct migration to cloud. Or you have the rebuild and migrate option, which also is perfectly acceptable depending on the route you're going. Oftentimes you'll find that people moving to a cloud service will run in parallel for a little bit of time, but the actual implementation stage is actually the easiest stage of this entire process, in reverse to a normal process. So with an infrastructure project, the planning is super easy. The servers turn up. It's the migration that is the bit that you will stress about, because you're moving from platform to platform. For me, moving to Azure or AWS is the opposite way around. You're actually, the planning is the bit that's stressful, and getting that right and getting that understood correctly and getting the buy-in, because it's a massive change. The technical implementation of lifting and shifting the servers or changing the environment is something that's documented. We do it a lot. We know it works really well, and there's the support from the vendors to do so. So another question come in. Sorry, Adam, I realise I am taking all the questions. I think you answered your security bit so well that no one's come back on security.
I'll take it as a compliment. It's fine.
So in terms of, someone's asked a question of, we're just about to invest in brand new on-premise servers. Should I still look at the cloud? If you've just invested in servers, it really depends on how long you're intending to sweat that asset for. So if you buy servers on the intention of sweating them for 5 years and you've just purchased them, then yes, look at the cloud, but look at new workflows, things that you weren't planning to do. Just lifting your on-premise servers now will be counterintuitive. Now, if you're just about to enter that cycle of looking for new servers, stop and have that cloud conversation now, because realistically, in around 5 or 6 years' time, there will be very little on-premise servers for most SME, SMB, and mid-market businesses, because the cost of manufacture for those servers is so high to the likes of Dell, HP, and Lenovo. They won't continue to make them at a competitive price, because they won't be able to compete with the scale of Azure or AWS. So that's where we see the market going. The market is moving away from that. So if you've already invested, obviously sweat them for as long as you can, but obviously be ready to make that move. If you haven't already purchased servers and you're just about to hit that refresh cycle, then start looking now, start having the cloud conversation, and look at maybe doing a hybrid cloud for the next 5 years, with the thought being that you'll be full cloud by 2030 or even just before then. It's a case of now is the right time to be having this conversation. A lot of people went the other way when we look at this from the lessons we learned from Microsoft 365, which is people stuck with on-site Exchange for a very long time, thinking that 365 was just going to go away. It's now not. Now 90% of businesses are on 365. Exchange is a dying product. And ultimately, those people that haven't moved already have got a very painful time now of getting off of their Exchange environments and moving to cloud. So it's better to be in front of these changes than one of the people that are chasing behind it, trying to catch up. Because also, as a competitor in your space of the market, someone who's moved to cloud might have better services than you because of moving to the cloud. It's always a case of getting that competitive edge over everyone. Now, I don't think any more questions have come in, and that's kind of perfect, because I'm just looking at the clock. We're just about to run out of time on this session. So I will wrap that up there by saying, thank you for everyone that has attended today and everyone that has asked questions and got involved. If there's something you'd like to ask on a one-to-one basis, as I said, you've got, I'll bring our details back up onto the screen, and feel free to reach out at any point. We're there for you whenever you need us. Obviously 3 in the morning might be a bit inappropriate, but I'm sure that one of us will still answer our phone. Thank you again for giving us your time, and we hope that we'll see you on the next event on Thursday, 29th of July. Thank you very much.
Cheers, guys.